Okay, sir.
Hello, Tracy. Is Tracy on the line? Hello, Tracy. Hello, Tracy. Monica.
Yes, sir, I'm here. Hello.
Hello, Tracy.
Yes, sir.
I hope you can start recording now.
Sir, please, I've started.
I'm saying you can start recording.
Okay, sir.
Hello, Tracy.
Okay, sir, I will start recording.
I said you can start recording now because we are beginning.
Okay.
Yes, so start recording. All right. Hello, class. The whole course is divided into about 2 sessions. We have the first part is electricity, and the second part is about waves and light and sound. And with the electricity aspect, 2 parts. We have static electricity and current electricity. And then when you come to waves, we have optics, that is light, and then we have sound waves. So let's begin with the first part, electricity. So, as I said, electricity is the study of electric charges either at rest or in motion. Electricity is the study of electric charge or electric charges either at rest or electric charges in motion. When the electric charges are at rest, the study of electric charges at rest is called static electricity. And when electric charges are in motion and we make any study about them, we are in current electricity. So we are going to begin with electric charges at rest, study of electric charges at rest, which is static electricity. Now, so the whole study is about electric charges. Question is, what is an electric charge? To begin with, an electric charge is a property of matter by which matter can exert an electric force, either attraction or repulsion. Hello, are you with me?
Yes, please.
Sir, please, where are you taking it from? Because in my module, section,
We don't know where you start from.
Section 1.
Section 1. Section 1, unit 1, section 1 is some basic properties of light. So I don't know the information they are giving us now.
General physics 2.
Yes, sir.
Theory 2.
Yes, please.
What you are doing is the physics for the. It's not the elective for the science courses. This one, we are doing the general physics theory 2. So our first lesson is introduction to optics.
General physics 2, right?
Yeah, theory 2.
Hello.
Sir, please, we are general physics theory. Hello.
Hello, sir.
The course is general physics 2, right?
No.
Yeah, that is what sir is reading. The same thing. Introduction to optics, unit 1. And section 1 is some basic properties of light. The same thing.
W. Sir is reading general physics. But the
This mark says reading electricity aspect.
Sir, it is general physics theory 2. Sir, we have general physics and general physics theory 2. We are doing the theory 2, please.
What
Which
he's reading is the general physics. We are doing theory too.
yes. So where it started from light, the basic
Properties of light. Yeah.
yes. But what we are reading is for the general physics, whereby theory is not part of their own.
The same thing I say no radio, the same thing.
Yeah, blah,
The
the same.
same thing.
Bismarck. Wait, what, one? Can you hear you?
It's introduction to optics. Introduction to optics or your theory tuning. Page 1.
Uh,
Page 1.
but so you heard that he started
Introduction
defining
to optics.
what is electricity and type of Bismarck.
Bismarck. Say it's talking about electricity. We don't have electricity. We are starting from light. Say it's talking about electricity. Introduction to optics is in every module. It is in every module, but the content, the sections is what we are talking about. But say it's talking about electricity, whereby we have light.
Hello, class, group.
Sadiq.
Hello.
Sadiq.
Please, please. I have my model. The code is EBS216D. Please, I hope somebody is also having the same model.
Yes, that is the code. That is the code.
Then you have to ask the lecturer the code that maybe is using different one.
Using the general physics phone. Is even out of the context. He's not on the line.
Because that I quickly checked through page unit 234, but I can't find it. Then that's why I drew his attention.
He was teaching general physics, not general physics theory.
So please guys, does it mean that we are the wrong page or what?
No,
Yeah,
say that made the mistake.
He's using
maybe,
the wrong book.
yeah, maybe.
So the error is from Say, right?
Yes,
Yes, the
Because-
error is from
because-
him. He's using the course for the primary and the BEC. They are doing the general physics, and then those that are doing the science and the maths, they are doing the general physics theory too. So we are doing theory, and then they are just doing the general physics.
But Mr. Bismarck, you are presenting your page. Present and let's see what you are talking about. The introduction to optics is in every module.
Please, in my module, page 165, is where that you have the static electricity. That is unit 3, page 165. Is there that we have static electricity? So I don't know where.
Yes,
We are not yet there.
Yes, that is it. So we are not yet there at all.
Yeah, time about
I don't remember. I was about to.
I don't remember. Oh, Jesus.
Bismarck, please forward what you have onto our platform for us.
Hello.
Hello, sir.
Yes, hello.
Hello, sir.
Yes, I'm listening.
Sir, you were saying that the module in front of us, what we are having here, what you were reading to us is quite different from what we have on unit 1, section 1.
It's different.
Yes, sir.
Okay. Okay, so let me cross check and see, because The general physics, there are a number of them. So let me just cross-check and see which one you sent to me.
All right, sir. It's general physics theory 2.
General physics theory 2.
Yes, sir.
Okay. And okay, let me see.
And in our module, unit 161 is some basic properties of light.
Basic properties of light.
Yeah, it's where that it starts.
Okay, let me cross-check and get the right textbook so I can be in sync with you.
All right, sir.
Basic
Thank you.
of light. That is a general physics theory 2, right?
Yes, sir.
Okay. Just a minute. Let me make some checks and then I get back to you. Just stay on. Okay. All right. Hello. Hello.
Hello, sir. Hello.
Yeah, I think I have the correct model now.
Okay.
Yeah, I think I have the correct model now. In order that we be on the same wavelength, right?
Yes, please.
Let me just recount some of the units so we can agree on it, right?
Yes, sir.
Hello.
Yes.
Unit 1 is Introduction to Optics, right?
Yes, please.
And then some basic properties of light, okay?
Yes, please.
Section 1. Section 2, reflection on a plane surface. Section 3, reflection on a curved surface. Section 4, reflection on a plane surface. Section 5, refraction on a curved surface. And section 6, optical instruments. I hope that is the correct one.
Yes, please.
Okay, so we can use this. We can use this one. Yeah, we can use it. We can use it. So there are several general physicists. So I was not in. Okay, so I think I have the correct textbook now. So we can begin. Okay. Now, so I think the course is divided into, I think, 3 or so. Yeah. Hello.
Hello, sir.
Yes, sir.
Yeah, the course is divided into about 3 pieces. We have basic properties of light, in other words, light. And then after light, we have a sound waves. Yeah, we have waves. Unit 2. Unit 2 is waves, right? Hello.
Sir.
Hello, sir.
Unit 2 is waves and acoustics, right?
Okay.
Flip through your paper. Unit 2 is waves and acoustics.
Waves and acoustic. Yes, sir.
Okay. And then unit 3 is static electricity, which begins from page 165, all right?
Yes, please.
Yes, sir.
Yes, please.
Okay. And then, of course, we have current electricity. So that is all there is for your course. So we'll begin with some basic properties of light. Okay. All right. So let's start from there. Well, I hope you're all listening to me.
Yes, sir.
Now, what we refer to as light is among a group of radiations called electromagnetic radiations. Electromagnetic radiations. And light is just one of those electromagnetic radiations. But the difference here is that light is visible. So light can be described as an electromagnetic radiation that is visible to the eye. That is the meaning of light. The other members that are also electromagnetic radiations, you can list them down. That's the EMR, electromagnetic radiations, are gamma rays. I hope you are writing.
Yes, sir.
Gamma rays. We have X-rays. X-rays. We have ultraviolet rays. And then we have visible light, the one that we are coming to study. Visible light. Then we have infrared rays. Infrared rays. And then we have radio waves. Radio waves. And finally, we have microwaves. 1, 2, 3, 4, 5, 6, 7. All these 7 are called electromagnetic radiations. But only visible light can be seen by the eye. The rest cannot be seen. Hello, are you with me?
Yes,
Yes, sir.
please.
So what is light? Light is an electromagnetic radiation that is visible to the eye. Now, light has two properties. It is made up of particles we call photons. Photons. So light is a particle. So when somebody shines light on you, the person has thrown particles, it means it has momentum. Light has, those light particles have momentum, and they also have energy. Are you with me?
Yes, sir. Sir,
Hello?
but
Yes,
your
sir, but your
network
network that is breaking.
is not helping.
My,
So your network
the network is breaking.
Yes,
is
please.
not helping. So
So
we couldn't hear what you said, but you said we have two particles, but you didn't hear
light
the
has
rest.
properties or has two properties. It is a particle, all right,
Yes, sir.
called photons. Photons. So when somebody shines light on you, it is similar to somebody throwing billions of particles on you, and each particle is called a photon. Now, because light has a particle, it's a particle like a piece of stone, it has momentum. Momentum is mass times velocity, and it has energy. We will come to all those in future. Okay. The other property of light is that it is a wave. It is a wave. It means it has frequency, and it has wavelength, and it has velocity. So light is both particle and a wave. The particle nature of light comes from studies of photoelectricity, photoelectric effect, and then Compton effect, Compton. These two studies show that light is made up of particles. The other study, which shows that light is a wave, comes from the fact that light can undergo interference, and it can undergo diffraction, it can undergo reflection, and it can undergo refraction. So the fact that light can be reflected means that light is a wave. The fact that light can be refracted means light is a wave. So if you are asked to name any property of light which shows that it is a wave, you can mention interference, diffraction, reflection, and refraction. These are the properties of light that make it a wave. If you are asked to mention any property of light that shows that it is a particle, then you can mention photoelectric effect. And then you can mention the Compton, C-O-M-P-T-O-N. Compton effect. Are you with me?
Yes,
Yes,
please.
sir.
Now, so that is about light. Now, the visible light that the eye can see, when you place
Please,
a
question.
triangular,
Please, question.
okay, go ahead.
Yeah, I learned that light is not a matter, and with this reason that uh, it is saying that light is having particles. Does it qualify it to be a matter since there are particles in light?
Yes, light is not matter, but it's made up of particles called photons. Matter has mass, right? Hello?
Yes, sir.
Yes, please.
Uh-huh.
Yes, please.
Matter has mass, but light particles have no mass. They are massless, and we call them photons. Photoelectric experiments and experiments involving Compton effect show that light is made up of particles. So light has two natures. A nature as a particle called photon, massless photons, and also a wave, like sound wave, like the way sound behaves, light behaves in the same way. For instance, light can undergo reflection, it can undergo refraction, and these are properties of a wave. So if light can undergo reflection, refraction, diffraction, and interference, it means light is a wave. Also, light is a particle called photons, and these particles can interact with other matter like electrons and protons and transfer energy to them in a study called photoelectric effect. So in effect, light is a wave like sound wave. It is also a particle, but it has no mass. Are you with me?
Yes,
Yes, sir.
please.
It is massless.
Yes,
Massless particles
and
called photons.
okay, sir. And sir, please, from the lecturing, may I know if there is a difference between radiation and waves? Because it seems I am too confused with those two words, waves and radiation.
Okay, later we shall study about waves, all right? Any
Oh,
anything that can undergo reflection, refraction, interference, diffraction, and polarization is a wave, like sound wave, like light waves. You know, light can be reflected, right? When you shine light
Yes,
towards
please.
a mirror, it gets reflected. Okay? And when you shine light in water or any transparent medium, it gets refracted. This means light is a wave. In fact, the fact that light is a wave was proposed by a scientist called Christian Huygens. Christian Huygens proposed that light is made up of waves. Then Isaac Newton and Einstein also proposed that light is a particle. So in general, light is both particles and waves. Now, a radiation is anything that comes out from a source. Like when you set up fire, right? And you stand a little distance away, you feel the heat. And we say the heat radiates from the source. So anything that comes out from a source, like heat or light or any electromagnetic wave, is a radiation. Okay, so heat is a radiation because it can come out, it can spread from a source through either matter or empty space. and that is a radiation. So to say that light is a radiation means it comes from a source and spreads out. All right. Hello.
Hello, sir.
Aha.
Thank you.
Aha. Okay. Now, so let's concentrate on visible light. Now, when you pass visible light, white light from the sun, white light, through a triangular glass prism, a glass shaped into a triangular shape or made into a shape of a triangle, a prism, a triangular glass prism, then the light, white light, will be split into 7 different colors. And the fact that a triangular glass prism splits white visible light into 7 different colors is called dispersion. So dispersion is the splitting of white light into the component 7 different colors. Now, what are these colors which come from white light when it passes through a triangular glass prism? The colors are, from the bottom, we have violet. You've heard this one, Roy. Okay, violet. Violet.
Indigo.
I'm starting from the bottom of the triangular glass prism. If you pass white light through, from the bottom you have red, next is orange, next is yellow, next is green, next is blue, next is indigo, and the last one is violet. So from the triangular glass prism, the one at the bottom who is violet, then followed by indigo. I'm starting from the bottom, right?
Okay,
Yes,
sir.
sir.
Okay, sir.
Violet, indigo, blue, green, yellow, orange, and red. If light passes through a triangular glass prism and you start from the top, it will be red, orange, yellow, green, blue, indigo, and violet. These are the component colors of white light. So white light is made up of 7 different colors. Now, above the red is a radiation which cannot be seen by the eye. It's called infrared, above red. And below violet is also a radiation which cannot be seen by the eye. It's called ultraviolet. So in between infrared and ultraviolet, which cannot be seen, we have red, orange, yellow, green, blue, indigo, and violet, which can be seen by the eye. I hope you are with me.
Yes,
sir.
please.
Okay. So this is the component of white light by a process called dispersion. Now let's look at the sources of light. Sources of light. So the next subtopic is sources of light, where we get light from. Okay, now we can get light from 2 main sources. We have natural sources of light and then artificial or man-made sources of light. So natural sources and then artificial sources. Now, what are some of the natural sources of light? Can you tell me some?
Yes, please, sun.
Okay, mention some natural.
Sun,
Yes,
sun, moon,
the sun is a natural source of light. Did you say the moon?
Yes, sir, he said it.
Okay, the moon is not a natural source of light. The moon is like a mirror. It only reflects light from the sun. So the moon is not a source of. That is why sometimes it disappears. When it is out, it's in the shadow of the sun, that we cannot see it. Okay?
sir, please
So the
question.
moon,
Sir, please, why is it that when it's light out and then the moon comes, it's able to bright to the point that you can see? That made
okay,
me mention the moon.
here is the answer. The moon is like a piece of stone. It doesn't produce light. But when light from the sun fall on it, then it will reflect the light as if the light is coming from it. The moon does not produce light. So if in the dark, you still can see the moon, it is only reflecting light from the sun to your eye. That is why you see the moon as it is. But the moon does not produce light. Okay?
Okay, sir.
Now,
And,
anybody
sir,
yes.
sir, I also learned the luminous bodies and the non-luminous bodies, whereby the
Yes,
luminous bodies are the one that
yes.
can produce
Anybody
light
that
on their
produces
own.
Anybody that produces light by itself is luminous.
Luminous.
And a body that does not produce light by itself is non-luminous. All right?
Yeah, so I was trying to say that then moon is a non-luminous source of light. Or
It doesn't produce light, so it's not a source of light. Don't say the moon is a source of light.
okay,
The moon does not produce light at all.
okay,
So the moon is non-luminous.
okay, okay.
Now, if anybody that produces light is luminous. Now, these luminous bodies that produce light, there are two kinds. We have the natural ones and the artificial ones. The natural ones, you mentioned one is the sun.
Fireflies.
And then we have
Fireflies.
blue light. These are fireflies. They produce light naturally. So they are natural luminous bodies like the sun.
Sir,
Okay, then we have
what about
birds. Yes.
what about the stars?
Yes, a star is a sun.
All right, sir.
A star is a very distant sun. So it also produces light. And
Thank
then
you,
we
sir.
have certain fishes in the sea. Certain fishes in the sea also produce light. Those who go to sea at night, sometimes certain fishes produce light and they can see them in the dark. So these fishes also produce light. And then certain worms in the forest also produce light. So these are natural light producing objects. The sun, we have the stars, we have certain fishes in the sea, then certain earthworms produce light by themselves. Then when there is lightning and thunder, right? when lightning and thunder occurs, light is produced. This is also natural. And then volcanoes. Volcanoes. I hope you are writing down some notes.
Yes, sir. Sir, please.
Volcano. Okay.
You mentioned that some fishes are light.
Yes, I'm listening to your question.
Yes, so please, so some of us are writing. So want the names of those fishes and then the words, so that when we are asked, we can put down their names.
They are called deep sea fishes.
Oh, your line is breaking badly.
Please, they are called.
They are called deep sea fishes.
Okay.
Yes, so certain deep sea fishes produce light, and certain worms in the forest also produce light. And then fireflies produce light. When there is lightning and thunder during a rainstorm, we also get light from lightning and thunder. We also get light from a volcano. When there's a volcanic eruption, light is also produced. Okay, and then when you strike two stones against each other, you strike two stones against each other, light can be produced. And these are natural sources of light. Now, apart from this, we have artificial sources, those that scientists make, like the bulbs, the LEDs, and then the fire that we set, and incandescent bulbs and fluorescent bulbs. These are artificial sources. All the light we use in our homes, either fluorescent tubes or LEDs or incandescent bulbs, these are artificial candles. These are all artificial sources.
Hello, sir.
Light. Yes.
Yeah, I've been seeing cats and dog. At times, at the night, you will see that their eyes will be shining so high, like there will be light at the eyes of the cat and the dog. So I want to know,
Yeah,
are those people are those animals producing light?
Those animals, they have certain pigments in their eyes, that they don't produce light by themselves. Okay. But when
They
light
only
falls
reflect
on them,
light.
they reflect it back. You get me?
Yes, sir.
Their eyes don't produce light, but anytime when light falls on their eyes, then it's reflected as if the eye is producing. It's like the moon. It doesn't produce light, but when light falls on it, it's reflected. It's like a mirror. A mirror doesn't produce light, but when light falls on it, it's reflected back, and you think the light is coming from the mirror. That is how it is.
So does it mean they are non-luminous?
Yes, their eyes don't produce light. No. Okay. So that is about the nature of light. Now, there are others which I will mention as we move ahead. So let me go to page 6. Page 6. The question is, how do we see things? How do we see around? How do our eyes see objects around us? How do you see the book that you are holding? Now, for you to see any object, there must be a luminous body around. Then the luminous body will produce light. The light will fall on that object, and the object will absorb some of the light and reflect some. The part of the light that is reflected, when it enters your eye, then you have seen the object. That is how the eye sees objects. First, there must be a luminous body in the environment. Light from the luminous body falls on that object, and the object will absorb some of the light that is falling on it, and then reflect the rest. The part that is reflected, when it enters your eye, then you have seen the object. If the light is reflected, if the reflected light does not enter your eye, you cannot see the object. That is how we see things. But how do we see objects in different colors? For instance, when you look at a leaf, it appears green. When you look at a ripe mango, it appears yellow. How does this happen? Okay, remember, we told you that light is made up of a bunch of colors: red, orange, yellow, green, blue, indigo, and violet. So let's take a green leaf, for instance. When white light falls on a green leaf, the leaf will absorb all the other colors and reflect only green light to your eye. So your eye will see the leaf as green. When you see a ripe mango as yellow, what happens is that white light from the sun falls on the mango. The mango will absorb all the other colors, the 6 colors, and reflect only yellow light to your eye. So your eye will see the mango as yellow. In the same way, when you see a ripe tomato as red, white light from the sun falls on the ripe tomato. The tomato will absorb all the 6 to your eye, and you see the tomato as red. Hello.
Yes, we are listening.
Your line is blocking.
Class, are you with me?
Yeah, with
Yes,
you, but your
please.
line
We are
is
with you.
Yes, yeah.
Hello.
Sir,
Hello, class.
sir, we are with you, but your network that is breaking small.
Hello, class.
Hello, sir.
Hello, sir.
Hello, class.
Hello,
Yes,
sir.
sir.
Hello, sir.
Hey.
Sir, we are here. Why is your network?
Your network is not helping us.
The network is bad. I just explained how we see objects around us.
Yes,
And
sir.
can I repeat that one?
Yes, please.
Though we
Okay.
get it.
Okay, so question, how do we see objects around, especially in their colors? Let's take a ripe tomato, for instance. A ripe tomato appears red to the eye. Question, how does a ripe tomato appear red to the eye? This is what happens. Light from the sun falls on the tomato. The tomato will absorb all the other 6 colors and reflect only red light into our eyes. And because the red light is reflected from the tomato and is hitting our eyes, our brain thinks that the tomato is red. Now, how do we see leaves as green in color? For us to see leaves as green in color, white light from falls on the green or on the leaf. The leaf will absorb all the other colors and reflect only green light towards our eye. And when this green light from the leaf enters our eye, the brain interprets it as the leaf being green. So to see any color of an object, the object must reflect that color towards your eye, and then you can see the object as the color. Now, if you see an object as black, hello, hello,
Hello, sir.
hello,
We are here.
Hello, sir.
hello,
Hello, sir.
hello.
Hello, sir.
Hello, sir.
Objects that appear black to us, they don't reflect any color at all. They absorb all the colors of white light and they don't reflect any at all. I'm continuing. Hello.
Hello, sir.
Hello, Frimpong. I'm continuing. I'm saying that objects that appear black to our eyes, such objects don't reflect any color at all. Yes, hello.
Yes, sir.
I'm
Sir, please, we are
explaining
with you.
how objects. I'm explaining how objects appear black to our eyes.
Yeah.
Whenever object appears black to our eyes, that object absorbs all the white light, different colors, and reflects none to our eyes. That is why objects appear black. And if an object appears white to our eyes, it means it reflects all the 7 colors at the same time towards our eyes. So the object appears white. That is how we see objects, number 1. And that is how we see objects in their colors. Hello.
Sir, please questions.
Okay, go ahead.
Yeah. About what you are saying, some of the objects are not opaque at all. Mean like they can't even reflect. Some objects cannot even reflect light at all. But yet, some of those objects produce or have light. I mean, they have colors. So that one too, how is that possible?
Okay, I'm saying that for the eye to see any object, there must be some luminous body, especially the sun around. And the light from the sun must fall on that object, and the object reflects light towards our eye, and then we see the object. And I'm
Yes, sir.
saying that, so that is how we see. The object must reflect light coming from the sun into our eyes. Then we can see the object. That is how we see. Number 2, how do we see objects in colors? And I'm explaining that when you see an object like red or ripe tomato, which is red, it appears to your eye as red. How is it red to your eye? It is red because bright light from the sun falls on it. The tomato will absorb orange, yellow, green, blue, indigo, and violet. Absorb and then reflect only the red light towards your eye. So the red tomato appears red to your eye. That is how we see colors. Black is not a color. So if you see anything as black, it means that object has absorbed all the colors of white light and it has not reflected any to your eye. That is why it appears black to your eye. If you see an object white in color, it means that object is reflecting all the colors of white light towards your eye at the same time. That is why it appears white to you. An object may appear in a blend of colors depending on what combination of colors it is reflecting towards your eye. That is the explanation.
All right, sir.
Okay, now Let's look at the properties of light. So you can write properties of light. First, we said light is a particle and it's also a wave at the same time. It has particle wave nature. Number two, it can undergo reflection. It can undergo refraction. It can undergo interference. It can undergo diffraction. And it can undergo polarization, especially being transverse. It can undergo polarization. The other property of light is that it travels in matter. It can pass through transparent matter. All right? Hello?
Hello, sir.
Light can pass through transparent matter. Matter that is transparent, light can pass through it. The most transparent matter is vacuum, empty space. And light travels at a speed of 300 million meters per second in empty space. 300, that is 3 times 10 to power 8 meters per second in vacuum. But it can pass through other transparent matter with lower speed than what I have mentioned. So these are the properties of light. Light also travels in straight lines. It's also another property. They travel in straight lines. When you shoot torchlight at night, you see that it will travel in a straight line. We call this property of light the fact that it travels in straight lines as the rectilinear propagation of light. Page 6, rectilinear propagation of light. The fact that light travels in straight lines, rectilinear propagation of light. Okay, now I hope you are with me.
Yes, please.
Yes, sir.
Okay, now when light, this is the other property, when light passes through an opaque object, like vacuum. Now, there are other objects light cannot pass through. We call them opaque objects. And anytime light encounters an opaque object, it produces a dark region behind the object called the shadow of the object. So light can produce shadows behind opaque object. An opaque object is one in which light cannot pass through. In other words, when light falls on an opaque object, the object will absorb all the light. Okay, it may reflect some very weakly, but it will absorb much of it and cast a dark region behind the object we call a shadow. So anytime you see a shadow, it means light is falling on an opaque object. Okay. Now, the fact that light can form shadows behind opaque objects is the reason why we have solar and lunar eclipse. Something astronomical. The reason why we have solar and lunar eclipse. Are you with me?
Yes, please.
The reason why we have solar and lunar eclipse. That is on page 8 and 9. So I will advise you to, it's just a text. You can read about how solar eclipse are formed, how lunar eclipse are formed. Read about that one. Okay, read about solar and lunar eclipse, eclipse of the moon, eclipse of the sun. You can read about that one. These are just texts. Okay, so let me go to session 2. Read about solar eclipse and lunar eclipse. These are just very simple texts which you can understand. Let's look at session 2. We have a long way to go, so we are looking at session 2. Okay, now session 2 is about one of the properties of light. We mentioned that light has a number of properties, and among the properties of light is reflection. We are going to look into reflection and study more about it. Now, what is the meaning of reflection? Reflection is the bouncing back of light when it meets a shiny surface or a surface. So, for instance, when you place a mirror against a wall and you shine light on it, then it will send the light back towards you. And we say reflection has occurred. And we say reflection.
Hello there.
Yes.
Please, must the definition only be on a plain mirror?
No. I told you that for anybody to see, for us to see any object around us, the object must reflect light. So for your friend to see you, light must fall on you and your body must reflect the light towards your friend's eye, and then your friend has seen you. So everybody reflects light, right?
Okay, sir. Thank you.
Including the moon. And everything that you can see around you reflects light. But for the purpose of our study, we are going to limit ourselves to plain surfaces like plain mirrors and curved mirrors. All right? So
Okay,
what is
sir.
reflection? It is the bouncing back of light after falling on a surface. And as I said, everybody reflects light except a body which appears black to our eyes. Okay, so that is reflection. Now, the light, so let's take a mirror for instance. You put a mirror against a wall and you get a torchlight and you send light towards the mirror and the mirror reflects the light back, just as the moon reflects light from the sun back to the earth. Now, the light from the torch which hit the mirror, hello? The light from the torchlight which hit the mirror is called the incident light or incident ray. The light that comes from the mirror after reflection is called the reflected light or reflected ray.
Sir.
Are you with me?
Sir. Yes, sir. Sir.
Are you with me?
Sir, please. Yes, sir.
I want to enlarge my screen. I want to enlarge my screen. Okay, so are you with me, class?
Yes, sir.
Hello.
Hello,
Hello,
sir.
sir.
Yes, okay, yes, sir.
Are you with me?
Yes, please.
Yes,
Is the class with me?
Yes, please.
Yes, we are here.
Yes, sir. Yes, sir.
Yes, sir. Yes, sir.
I hope the class, you are with me.
Yeah.
Yes, please. Yes, sir.
Okay. I was saying that when you shine light from a torchlight onto a mirror, the mirror will reflect the light back to you. The light will come back. And the light that came from the torchlight towards the mirror is called the incident light or incident ray. The light that comes out of the mirror or from the surface of the mirror after it has reflected is called the reflected ray or reflected light. The point where the light hits the mirror surface is called point of incidence. Point of incidence. And when the light hits the mirror exactly at right angles, the light will return along the same path. If you adjust the light, source of light, to hit the mirror exactly at 90 degrees to the surface of the mirror, the light will return along the incident ray. This light, which contains both the incident ray and the reflected ray, is called the normal. The normal makes 90 degrees with the reflecting surface. So we have the angle of, we have the incident ray, we have the reflected ray, we have the point of incidence, and then we have the normal or the normal ray. Now, what I'm going to talk about next is called the laws of reflection. When reflection occurs, certain statements govern the reflection, and we call them the laws of reflection. There are two of them, two laws of reflection. But before I go to the laws of reflection, anytime reflection occurs at a plane surface like a mirror, an angle will be formed between the incident ray, called the angle of incidence, and an angle will be formed between the reflected ray and the normal, called the angle of reflection. I'm repeating what I said. Anytime reflection occurs at a surface, an angle will be formed between the incident ray and the normal. This angle is called the angle of incidence. Another angle will be formed between the normal and the reflected ray. This angle is called the angle of reflection. The angle of reflection. Now, here are the laws of reflection. Anytime reflection occurs at a surface, the angle of incidence is always equal to the angle of reflection. So this is the first law of reflection. Anytime reflection occurs at a surface, the angle of incidence, which is the angle between the normal and the incident ray, is exactly equal to the angle between the normal and the reflected ray. We call this angle the angle of reflection, and the angle of incidence is always equal to the angle of reflection. So anytime reflection occurs and the angle of incidence is equal to 30 degrees, the angle of reflection will also be 30 degrees. If the angle of incidence is 60 degrees, the angle of reflection will also be 60 degrees. I hope you're with me.
Yes, sir.
Hello, class.
Yes, sir.
Hello, sir.
Yes, sir.
Hello, class. Hey. Oh. Hello,
Hello,
class.
Hello,
sir.
sir.
Please take that again, we beg.
Yes, we are with
Hello,
you.
sir.
Class, are you with me?
Yes, sir.
please.
We are with you.
Sir, please take that again.
Hello,
smooth,
class.
for a smooth transition, that's why you don't normally interject.
Class,
When
are
you
you
are
with me?
Yes, we are with sir.
Sir, we are with you, but the problem is there are blockages in your line.
Are you with me?
You're having it.
Yes, sir. We are with you.
We are with you.
Hello, sir.
Okay, I just mentioned the first
Hello,
law.
sir. Please
Yes.
take the loss again. It wasn't
Yes,
clear.
please. Yes.
Okay, the first one is that whenever a reflection occurs at a surface, the angle of incidence is equal to the angle of reflection. This is the first one. That is the first law of reflection. Angle of incidence equals angle of reflection. Now, the second law. Okay, now, when you draw reflection on your paper, the paper that your page, you draw a line representing the mirror, and then you draw a line on the surface of the paper representing the incident ray, another one, the reflected ray, and then another one, the normal, right? All these three rays, the incident ray, the normal, and the reflected ray, are all lying on the surface of your paper. Now, another name for a surface is a plane. That is another name for a surface. Now, the surface of a table is called a plane. And when you draw these rays on your paper, all these three rays will be lying on your paper or on the surface of your paper. So the second law says the incident ray, the normal ray, and the reflected ray, at the point of incidence, all of them lie in the same plane or they lie in the same surface. This is the second law of reflection. Whenever reflection occurs, the incident ray, the normal, and the reflected ray at the point of incidence, all these three rays lie in the same plane or lie in the same surface. This is the second law of reflection. I hope it's clear.
Yes, please.
Are you with me?
Yes, sir.
Please.
Francis, Frank, are you with me?
Yes,
Yes,
please.
I'm here. Thank you.
Yes, please.
Okay.
Hello, Zai.
Did you hear the second law?
Yes, please,
Yes,
I did.
please.
Thank you.
Okay, so I'm going to state the laws of reflection again. I said anytime reflection occurs at a surface, one, the angle of incidence is always equal to the angle of reflection. And two, the incident ray, the normal, and the reflected ray at the point of incidence all lie in the same plane. And when I say plane, I mean a surface. So when you draw all these three rays on your paper, all of them will be lying on the surface of your paper or lying on the surface of the plane of your paper. So all three rays lie in the same plane. That is the second law. So you should not be surprised if you are asked to state the laws of reflection, right?
Yeah, you will not be
Okay.
surprised.
Yeah. Okay. So I'm moving on.
Sir,
Now,
sir, please, can you talk about the types of reflection? Because
that is what
the types of it seems from the book, they said
yeah.
they will form parallel lines, but how
Hold
they
on,
have
hold on,
drawn it.
hold on, wait. Hold on, wait. My next subtopic is types of reflection.
Okay.
Types of reflection. That is my next subtopic. Okay, now listen to this. When you stand in front of a mirror, right? You can see your image because of reflection. All right? When you stand in front of a mirror and there is light around, light from you hit the mirror and the mirror reflects the light back to your eyes and you see your image in the mirror. The mirror reflects light and form an image which you can see your face in a mirror. Now, when you look at a white sheet of paper, when you put a white sheet of paper in front of you and you look at it, you will not see your image. Even though the white sheet of paper is reflecting light, but it cannot form an image. So in one vein, reflection in a mirror forms an image for you to see. Reflection in a white sheet of paper does not form an image. It means that the type of reflection in a mirror is different from the white sheet of paper. When you stand in front of a white marker board, you cannot see your image. You can see something like your image, but not clearly. But when you stand in front of a mirror, you can see your image clearly. In both cases, reflection will take place, but one can produce a clear image for you to see, and one does not produce any clear image for you to see, which means the two reflections, the one that occurred in front of the white in the white sheet of paper and the one that occurred in a mirror are different. Because of this, we have two different types of reflection. The reflection that produce the clear image in a mirror that you can see is called regular reflection. Regular reflection can produce clear image. This type of reflection can produce clear image for you to see. Now, the type of reflection that occurs in a white sheet or white paint, which doesn't allow you to see your image, is called diffuse reflection. Okay?
So please, can you give me the spellings for the diffuse?
Are you with me?
Can you please give me the?
Yes, sir. Sir, we are with you.
Class, are you with me?
Yes, sir.
Sir, we are with you. Can you give me the spellings?
Anchi, are you with me?
Yes, sir.
DIFFU.
Are you with me?
Please spell it aloud.
DIFFUSE.
Okay.
DIFFUSE.
Okay. Thank you.
The one presenting, please scroll up. It is there. Reflection, the meaning of reflection, scroll up, it will be there. The types, no, it is there. No, up, like go up.
Sir. Hello, sir.
Go up, go
Hello,
up.
Sir.
Sir, I've seen it.
That's it.
Sir.
Okay.
Sir, we are here. Hello, class. If somebody is near to say, you should tell them that we are here. Why? Oh, why are you laughing?
We are online. At a different end.
At times, he used to mention some people's names, so I thought is near to those people.
Oh no.
like those who join earlier, so their name just appear first. That's why.
Okay.
He's no more with us.
So with the specular reflection, but your own buyer will be for your room can play. And
so he first talked about the diffuse reflection before coming to talk about the specular.
He spoke about the meaning of reflection and later gave some the laws and came back to talk about.
But that's why I lost too, because the laws are down here. It seems like he jumped from there before coming here.
Yeah. It's true. He jumped, but Bismarck alerted him that.
And that's why he came back.
Yeah. But this area, you see that we have page 7.
Page 7.
He didn't touch on it at all. He just jumped like the para, like the diverging and the this thing, convergent beam of light. He didn't touch on it.
Which one? Which one? The rectilinear propagation of light.
Page 7. Are you there?
Page
Page
7
7.
When you
is the
talk about
light
it,
ray element.
he was explaining and it cut across. So you talk about it.
Uh,
Yeah.
Okay, the
So
line
the
wasn't
only
clear.
part he
The line wasn't clear. That
didn't
was
talk about.
when the line was giving us blockage and we highlighted him, but it
yeah,
seems
that he spoke about rectilinear propagation of light, but the types over there, you see that you have parallel, divergent, and convergent. That one is we didn't touch on it.
the model on the platform for us. Some of us are not having it, please.
Okay. Like this one, the one I'm sharing on the screen.
Yeah, come,
Okay.
come, 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 come.
Okay, I'm
Oh,
coming.
All right.
So I should put it on a platform, right?
Yes.
Okay. Okay. It's on a platform, please. So as you said, what you do is that you write your name, your index number, yeah, your name and your index number on the platform so that
Hello, Madam Tracy. Hello, the monitor from UCC. Please, oh, say it's not around. So can you please call him for us? Hello,
Just like
Madam Tracy.
it's like some 20 minutes left. So the one in charge of our names and registration number should prepare and take it.
you cannot do that. So unless maybe we should type it and put it on a platform. I'll compile all of them, then keep it, give it to the lecture.
So
Well,
if please
In case you people don't know, there is a monitor monitoring the online lecturing or activities, and she's on the line right now. So
and it's
that,
still being
that's the one
recorded.
I am. That's the one I am speaking with.
She's still recording. She's in the person of Emmanuel or something like that.
Yeah. So
say,
that I can say has joined into.
hello, sir. Nimpa bibini ni awaye ni.
But online there were challenges, bro. I don't know.
One your network, Papa wants to press.
Pious.
Yes.
Why?
As a teacher, no, quite on my idea.
What about or show you?
That's a network name.
We've left like 15 minutes view to go.
It's 28 minutes.
Network name. I want to walk off and break his call.
Now, yeah, point time by.
So what's your
I'll meet you. Bye bye.
Abba, Sadiq, keep
I see,
quiet.
this time around, the network is a nationwide though. You see, recently, whenever you're having online like this, it will be blocking.
And then you fought a network now.
Papa Sadiq, you keep quiet.
Oh, you say empty,
Hey,
empty.
you, why are you mentioning? Am I the only person here talking?
You are the one who don't mute yourself. You.
Oh, me cry. I don't know what I'm doing. Me need to cry. Do you want to why?
At least you have to make an idea of then the reflection that the idea and you bet me a cassava. Reflection of curve surface here. Unit session 3.
If at
So should we
least
continue?
you can read to our hearing maybe, and later someone also will explain it.
Sadiq, he said you don't know inside. Okay, sir is back.
Yeah, I'm back. Mute yourself and listen to me.
Okay, sir.
I'm talking about the different types of reflection. Now, listen to this. When you stand in front of a mirror, because of reflection, you will see your clear image behind that appears to be behind the mirror. And you see that image that appears to be behind the mirror because of reflection. Light from some source fall on the mirror reflects the light into your eye, and then you see yourself in the mirror as your image. You see yourself behind the mirror. Now, if you stand in front of a white piece of cloth or white marker board or white sheet of paper, this time you will not see your image as it appears in the case of a mirror, even though when your body reflects part of the light towards the white sheet of paper, and the paper will reflect back to your eye. But this time you will not see your image. Listen to me. I'm saying that when you stand in front of a mirror, light from some top fall on you. Your body will reflect part of the light towards the mirror, and the mirror will reflect it back to your eye. And then you see your image in the mirror. So there will be two reflections. One from the source of light to your body. Your body reflects the light towards the mirror, and the mirror reflects it back towards your eye, and you see your image in the mirror. So two reflections cause your image to be formed in the mirror. Now, when you stand in front of a white sheet of paper or a white cloth or a white marker board, still, when there is sort of light nearby, these two reflections will occur. Light from the source will fall on your body will reflect part of the light towards the white marker board, and the marker board will reflect the light towards your eye. But this time, you will not see your image. Now, the type of reflection that makes you see your clear image in a mirror is what we call regular reflection or specular reflection. This one produces a clear image in a mirror for you to see. This is the type of reflection. But the reflection that occurs on a white sheet of paper, a white cloth, or a white marker board, which does not produce any clear image for you to see, is called irregular reflection or diffuse reflection. So we have one reflection can cause a clear image for you to see yourself in a mirror, regular or specular reflection. And then one that will occur in a white sheet of paper or a white marker board or a white cloth that will not produce any image for you to see is called diffuse or irregular reflection. So we have two types of reflections: regular or specular reflection that produces the clear image in a mirror, and then diffuse or irregular reflection like the one that occurs in a white sheet of image. This is the diffuse or irregular reflection. Is the point made?
It's a question.
Is it clear? Is it clear?
Yes, sir.
Hello.
Clear. It's clear.
Hello.
That is clear. Sir, it's clear.
Hello,
We
sir.
understand.
Are you with me?
Yes,
Yes,
please.
please, sir. We are with you. We understand.
Friends, are you with me?
Yes, please, I'm with you.
Okay, now listen.
It's a
Apart from
question.
this,
It's a
we can
question.
use other, apart from what I just, okay. Okay, apart from what I just said, okay, apart from, okay, very good. Now listen, apart from what I just said, okay, you have a question, go ahead.
Hello, sir.
Ask the question.
Sir, please. I
Ask the question.
I want to ask
Isaac.
that's the two type of reflection.
Ask the question.
I'm asking, sir. My question is: there's the two type of reflection you just
Hello.
mentioned. Hello, sir.
Yeah, sir, he's asking the question.
Hello.
Hello, sir. Sir, I'm saying
Please,
that.
I'm waiting for the question.
Sir,
Yes,
he's
sir.
asking.
I'm saying
I
that.
see your line
Please,
is not
can
heard.
Okay,
you
can I continue?
can you hang it up and rejoin again?
Okay, I want to continue.
No,
Now,
can
apart from
you,
what I just said,
Ready?
we can also distinguish between
This man.
regular and irregular reflection by considering the following. With regular reflection, the one that produces clear image. Yes.
Sir, please, I'm saying that there's the two type of reflection obeys the laws of refraction, or sorry, the laws of reflection.
Yeah. Sadiq, I'm listening to you.
Sir,
Can't hear you.
my question is: there's the two type of reflection. That is the specular reflection and the diffuse reflection. That's all. They obey the laws of reflection.
Can I what?
I'm saying that.
Okay, let me
Sadiq,
start and rejoin again.
It seems say network is the problem here. Like he's far from us. So that's why I was saying that he should hang the call and rejoin again. Because right now, if you speak right now, I'll bet you know, be 10 minutes after.
Hey, this is a one more 450 nothing.
Hang it up. If you join the game, I think so. Be normal. I bet you ain't normal.
Please, who was asking the question?
Sadiq.
Sadiq, all both of them obey the rules, but the fact is, the other one, the regular one, where your image appear, you see, the law is talking about how the incidents and the reflected act. So if you throw a torchlight on a plane mirror, see, if you throw the torchlight on a plane mirror,
Please,
the ray
please, who
of
is
the
talking?
torchlight, is that what?
Who is talking? May I know you?
Is Prince.
Hey.
The ray, the incident will reflect ray. The ray of the light that will reflect, that will form the angles. But what he's discussing about, that one is not a light ray, but is about the reflection of your image. You understand? So we're talking about reflection based on the image, but not the rays. But the law talk about the rays. So when you throw the light, that is the light rays. So that light rays will give you the incidence ray and the reflection ray and the normal ray. But what he's talking about is not the rays, but he's talking about the reflection of the image.
So please, with this diagram, the second diagram.
This one.
Yeah. Does it obey the second
Is it this
law of
one?
reflection? Yeah, this one, the second one. The B.
This one.
Yeah.
Yeah, this one is talking about. This one does not obey. This one is a rough surface. When the light is, you see, what you are talking about is when it hits on the smooth surface. He has not talked about the rough surface. When it hits on the rough surface, yeah, you are not going to get the reflected ray like the way you have to get it on the smooth surface. That's why
Yeah.
that's
You
why he's
said
using.
all of them obey the laws of reflection, and now you are saying that the
No,
second one doesn't.
listen.
Yes,
What
that's what you say.
the type? Listen, the type that you are saying. This one is a rough surface. You understand?
You
And
need
when
to
the
explain
light
it well to him.
is that what?
Hello, can
You
you
need
hear
to
me
let
now?
him be aware.
Bro Prince. Bro
I
Prince.
think say
Yeah.
it in.
Can you
Okay.
hear me now? Hello,
Yes, sir.
can you
We
hear
can
me?
hear you.
Yes, sir, we can hear you.
Okay. Now, apart from what I just explained, that with regular reflection, a clear image is formed, like in a mirror. And with irregular reflection, there's no clear image formed, like the white sheet of paper, white paint, white marker board, white cloth.
Yes,
Now,
please.
when the reflection is regular, the one that produces clear image, anytime a beam of light, which is parallel, fall on the surface, the reflected light is also parallel, so no energy is lost. Okay? With regular reflection, parallel light fall on the surface, and the light is reflected also as parallel beam. So there's no loss of energy, or all the light move, the reflected light also becomes parallel. This happens when the surface is very smooth, like that of a mirror. But when the surface is rough, like that of a white cloth or a piece of paper, then because the surface is rough, the reflected light will be scattered in different directions and will not form any clear image. Even though the laws of reflection are obeyed in both cases, whether regular or irregular, the laws of reflection are obeyed at every point of incident. But with the irregular or diffuse reflection, when the surface is rough, the reflected light will be scattered in different directions and cannot form. So regular reflection is that with regular reflection, it occurs at a smooth, so that a parallel light is reflected as a parallel reflected ray. And because the parallel, it has diffuse reflection, the surface is rough. So when parallel light falls on the surface, the reflected light goes into different no clear image is formed. But in both cases, whether diffuse or regular, the laws of reflection are obeyed in both cases. at every point of incidence. I hope the point is made.
100% yes.
Hello.
Yes, sir.
Hello.
Hello, sir.
Yes, please, we are
Hello.
listening.
Hello.
Sir, we are listening.
Hello, sir.
I
Yes,
hope
sir.
that was
Yes,
me.
Yes,
yes,
please.
sir.
Yes, sir.
So look at what example 1.1.1. It says, why does okay, so I'm saying that the differences between regular and irregular reflection. So on the side of regular reflection, the surface is smooth. With irregular reflection, the surface is rough. That is one difference. Number two, with regular reflection, the reflected rays are all parallel. With irregular reflection, the reflected rays are scattered in different directions. Number three, with regular reflection, a clear image is always produced. With irregular reflection, no clear image is produced. So these are the differences between the two types of reflection. There are three. So if you ask to mention the differences between regular or specular reflection and irregular or diffuse reflection, you mentioned three things. One, regular, the surface, reflecting surface is smooth like a mirror. Irregular, the reflecting surface is rough like a white sheet of paper, a marker board, or a white cloth, or even the surface of a pond. Then number two, with regular reflection, the parallel light, the reflected light is reflected parallel. All of them move in the same direction, the reflected rays. Now with irregular reflection, the reflected lights are scattered in different directions. And then number three, with regular reflection, a clear image is formed like you have in a mirror. And with irregular reflection, like a white sheet of paper, no clear image is formed. So three differences will let you score all the marks. Okay, so here it's a look. Let's look at work page 14. Work example 1.1.1.1. It says, why does a rough surface diffuse? Diffuse means scatter a beam of parallel light. Why do a rough surface scatter light? What is the answer? The answer is that because the surface is rough, the reflected rays will move in, they will obey the laws of reflection, all right, but the reflected rays will move in different directions, resulting in the scattering of the light. Okay.
So you did not talk about
right. I hope
of light. You didn't talk about those two.
Say
so we don't know the difference between a beam of light and a ray of light.
A beam is a bunch of rays. A ray is a single light energy, right?
Yeah, but you didn't talk about it.
Single light energy is called a ray. A collection of these rays is called a beam. So a beam comes from a torchlight, right? A bunch of light energy moving together is called a beam. But a single light energy, we also call it a pencil of light. Just a single light energy is called a ray of light. Okay.
Yes, sir.
So
okay, sir.
That is it. So we see
sir,
the lot of reflection.
what makes the beam to be parallel, dimented, and hello, sir. So, how do we get the three different types of beam?
An object is seen in the
I am saying that how can we get the three different types of beams that we have concerning light?
Well, I'm saying that a beam is a collection of light energy, right?
Yes,
And
sir.
a
Yes, sir.
single light energy is called a ray. A collection of rays is called a beam, right?
Yes, sir.
Yes, sir.
Now,
And I'm
when this
saying that. And I'm saying that. So how can we get the 3 different types of beams?
okay, so if the beam, the beam is parallel, like it passes through, let's say, a prism, okay, a glass prism, and if the prism directs all the beam parallel, then we have a parallel beam. So like when you throw a torchlight, you have a parallel beam, okay? But the headlight of a car is a divergent, it spreads. It's called a divergent beam. So when you light a bulb, the light rays will spread in different directions, and it's called a divergent beam, a beam that is spreading. Okay, but when you pass the light through a lens, a lens, especially when you place the light at the focus, then the light will emerge from the opposite side as parallel, and you have parallel light. Also, because the sun is very far away from us, the light that reaches us from the sun almost travels parallel. So you can have a parallel beam of light, you can have a divergent beam of light. And when you focus light on an object, let's say in the night, 4 people all holding torchlight shine their light on you alone, then the light will converge on you, and we call it convergent light. So it's all the same thing.
All right, sir. Thank you a lot.
All right. Now, when you go to page 16.
Yeah, you said, come again.
I said a beam can be made parallel, can be made divergent or convergent. And when
Yes,
you
sir.
pass a beam of light through a lens, especially when you place the source of the light at the focus, then the light will emerge as a parallel beam.
Okay, sir, understood.
Okay. But when you get light, a torchlight, or from a single bulb, the light will spread the rays will spread in different directions and produce a divergent beam. But I'm saying that, let's say in the night, when people all shine torchlight on you, the light will be, all of them will be coming towards you, and we call that one convergent beam or convergent. So the light can be made parallel, divergent, or convergent, depending on what you want. Okay, now let's go to page 16. On page 16, there is a diagram there showing how the eye sees the image of an object in the mirror. All right, you see a mirror M, the shining surface is towards the left. There is an object there like a pencil labeled O, and there must be some sort of light around so that light.
Sir, please, the diagram that you are showing is different from what you are saying now. Please don't call.
On page 16.
But
go to page 16. This is page 16. Page 16 is showing how the eye sees the image of an object in a plane mirror. So you will see a mirror labeled M, and then you see an object like a pencil labeled O, and then you see the eye. Now, how does the eye see the image? And you see the image of the object drawn in broken lines behind the mirror. Now, how does the eye see the image of this object in the mirror or behind the mirror? First, light from some source must fall on the object O, and the object must reflect that light towards the mirror, and the mirror must reflect the light towards the eye. So there are two reflections. One, there must be a source of light. That source of light is not shown in the diagram. It's not shown there. But there must be a source of light, a luminous body, and then the source of light will fall on the object O. The object O will reflect some of the light towards the mirror. You can see those two rays coming from the point O of the object towards the mirror. And then the mirror will also reflect these two lights towards the eye. Now, these two rays that are coming towards the eye are diverging, they are spreading. Because of the way they were reflected from the mirror, they will be spreading out as they enter the eye. Now, when you produce these two rays behind the mirror, these two reflected rays appear to be meeting or coming from a point I behind the mirror, and that is where the image is formed. So this is how a plane mirror forms an image. First, there should be the object, a mirror, and then the eye, and then a source of light. Now the source of light will produce light to fall on the object. The object will reflect the light towards the mirror. You can see those two rays from point O of the object towards the mirror. Now, the mirror will also reflect the light towards the eye, but these reflected rays towards the eye are diverging, they are spreading out. When you produce these two rays towards the eye behind the mirror, they appear to be coming from point I behind the mirror, and that is where the image of the object is formed. So the image of the object is formed behind the mirror because the two reflected rays diverge towards the eye. And when you produce them behind the mirror, they appear to be meeting or coming from point I, and that is where the image of the object is formed. So this is how an image of an object is formed.
This one is too practical. Like, the understanding is not that clear. Why do I tricky kakra? It's supposed to be practical. That's why we don't do science online. This is too practical.
Okay, so when I finish, take your mirror and stand in front of it. Take your mirror, stand in front of it, and you get everything clear. I'm saying that first there should be light in your room. If darkness in your room, reflection cannot take place. So there should be light in your room. Then light from your room will fall on an object like a pencil. The pencil will reflect the light towards the mirror. So you see those two arrows coming from the object towards your eye. Now, these two rays that are coming towards the eye are spreading out. They are diverging. So, but when you produce them behind the mirror, they appear to be coming from point I behind the mirror, and that is where the image of the object is formed. So this is how a plane mirror forms an image. Now, what are the properties of this image formed by a plane mirror?
The eye.
On page 16. This image formed by a plane mirror has certain properties. What are the properties of the image formed by a plane mirror? One,
Hello, sir.
The image appears upright. It stands upright as the object. So if the head of the object is upwards, the head of the image will be also upwards. So number one, yes. Number one,
Please,
the
I'm
image
saying
is
that.
upright. Or you can say the image is erect. That is property number one. Hello.
Sir.
Hello, sir.
Okay. So
Yes, it's time.
It's not time. Sadiq.
okay, let me finish with the property.
It's not time.
Let me finish with the properties and then we can end it from there. One, the image is upright or erect, which means the image stands up the same way as the object. So if the head of the object is upwards, the head of the image will be upwards. So the image is upright, or we can say the image is erect. You can write it now, properties of the image. One, the image is erect.
So please, can you explain that one again? The meaning of the erect.
Okay, so if the head of the image is upward, if the head of the object is upwards, the head of the image will also be upwards. If the legs of the object is downwards, the legs of the image will also be downwards. So we say the image is upright or erect. If the head of the image is up, if the head of the object is up, the head of the image will also be up. So the image is erect or upright. This is property number one. Property number two, the size of the image is the same as the size of the object. When you stand in front of a mirror, the size of the image is the same as your size. If you are fat, your image will be as fat as you. If you are slim, your image will be as slim as you. So the size of the image is always equal to the size of the object. That is property number two. Property number three, the distance from the mirror to the image, which we call image distance, is always equal to the distance from the mirror to the object. We call object distance. So when reflection occurs, the image distance is always equal to the object distance. Okay, so here is the next property. Now, when you stand in front of a mirror, are you with me?
Yes.
Okay, when you stand in front of a mirror and you raise your right hand, your image will raise its left hand.
Yeah.
And if you raise your right leg upwards, your image will appear to raise the left leg upwards. Have you noticed that?
Yes, sir.
Aha. This property is described by saying that the image is virtually Hello, are you with me?
Yes, sir.
Aha.
Sir, we can't hear you.
Okay, what I'm saying is that when you stand in front of a mirror, hello?
Hello, sir.
Yes, sir.
We are here.
When you stand in front of a mirror and you raise your right hand, you see your image raising the left hand. If you raise your right leg, the image will raise its left leg. That is what you see. We describe it to be the image is laterally inverted. The image is laterally inverted, which means when you raise your right hand, your image will appear to raise its left hand. And if you raise your right leg, the image will appear to raise its left leg. We describe this as the image being laterally inverted. Laterally inverted. The last property. Now, when you stand in front of a mirror, you see that your image will be behind the mirror, right? But when you pass your hand at the back of the mirror, you will not find anything there. We say that the image is virtual. Okay? The image in a plane mirror is virtual. So these are the properties of the image formed by a plane mirror. One, the image is upright or erect. Number two, it is laterally inverted. Object distance equals image distance. Size of image equals size of object. And the image is virtual. The reflected rays do not actually meet behind the mirror. They only appear to be meeting there. So the image is virtual. All right. I think the last five, and we will put it here.
Sir.
Yes.
So please, at this
Yes.
time, a magnification will appear or on the mirror.
Yes, but it's just a ratio of the size of the image to the size of the object. And because the size of the image is the same as the size of the object, the magnification is 1, or there's no magnification.
Okay.
The magnification is 1, which means there is no magnification. Size of image is the same as size of object, so there's no magnification, or the magnification is 1. The 1 means there is no magnification. So we'll end here and then continue next week. But next week, I think we can meet at the correct time so that we can have more contact with you. All right.
All right, sir.
So have a good day.
Okay, thank you.
Sir, please, I'm praying that next week you might not face a network challenge.
No, Sadek. Bismarck.
Yeah, I think.
You have to schedule your time to meet on the weekdays. So.
Sure, but depending lectures, you know.
So you have to inform the. I have to discuss with me.
Bismarck.
Yeah.
Yeah, Bismarck.
Yeah, me too.
Who's that? Physics, chemistry, those mathematics aspect of the at times who swim much about 2 hours. I'm over Keviano, Uncle Bibia.
Hey, I didn't clay.
This match, Uncle, are you in the same center? More the same center.
Yeah.
Pius.
Oh, Charlie. Anyway, on the slow.
Hey, Pius.
Yes.
Hey, the American, I crash. Oh, yeah, mathematics, and I say science, another chemistry, science, you have 2 hours. Okay, I didn't see.
No, Pius, not you.
They never the lecture. I check me on Guardia. Oh, yeah.
So
you want me to check him? So cool.
Why are
chemistry? We should have
I chemistry. Hey, I'm like you know. I'm like you.
I come to see you.
I wish I had a man.
I come to know one man.
Come to one more.
Come to no man. I ain't no man.
Oh, I see.
We never know to go for a Friday, no, pa.
No, fella, no, say the wrong number. Wrong number say.
You know what kind there? If you know what's your friend now? On my times 2:30 by 4 so beba and I.
Different madam.
When not to get no.
But all of the catch coordinator now. Money to know about the last time. No.
Yeah.
As of the contact. Now say no I feel good for what divert no man. Oh I feel divert.
No, your friend says say I want to follow form now when provide correct details and UCC or very get to. Then if you're not maybe other day.
Maybe two say no I feel what divert. Obana is so cheating.
Just one me enter me no. Hello. Hello. Hello.
We are here.
Any relatives, no, any relatives, this work two are young crowd or debate thinking. No, yeah, no crowd.
And I also I don't want to work as one.
You need to slow.
Your daddy, that's what inside.
Hello.
Senior, Ojibwe says how Ojibwe fire of no you. Now me yes center me kwa me you me continue na me yes how Ojibwe thinking. But sabi you.
That's right.
Sare ga na village ana.
Hello.
Sadeku
Minti baby.
Online monitor online monitor also. Say so about no was yedia me cause I can say
one mama ya we kwasi on minti fi.
Who sare maka say yedina madam about so na can say each other ba.
Bismarck.
Tio
Charlie, I mommy a fix it day ne either say Tuesday and a Wednesday.
But you know say
or they man prior notice and
one thing is we have been meeting but we don't know our even personal contact one until we the one of us should create a group.
Hello.
Then you put it inside, then we join so that we get our personal details. Because we know lectures need to also. I say more I can bet you case. What else?
Not just who can track to lecture no be case and how can be a case.
Well, what kind of case? What's the guy on the ground on your case one?
I won't say a Dawson and a spending more Spanish and say you fix it day.
They now cannot or they consult lecture and they no what's on time maybe I do not my time and
that's not making say
so fix date now. No, I catch a lecture. Don't catch a lecture now because that day with me, you're quite that day with now. Who can catch on day? Our platform, our platform there was it's not safe. You to me, our platform was one of us will create a group. No, the link not to start group. Now you join.
All right.
You join, then we get to know ourselves well. Sad way.
Video call.
For chemistry theory 2 internet so I want to general platforms, man.
Chemistry theory 2.
Yes.
Yeah. Okay.
Now,
happy practical. What's the recommend campus?
Now this is why and then is our which say.
Other.
Happy practical. The recommend campus.
That's it.
Happy practical. The recommend campus.
Now this is the only and your crowd. Anna.
That's a practical recommend campus.
Happy practical. The recommend campus.
I don't catch you.
From what's the owner of Casa? What you boy and why? You see, if what's owner of your voice when it's in boy.
I started going so I started here.
Oh, Malo, me, I'm in TBB, dear, on Fanchemi.
Now, let's know. You're born on a private lecture, but still that's so bad. You know, that's so bad. Where you won't pay.
I shouldn't.
So the other one.
They are saying it's time. Make us what's here. You have to make us when you are.
I usually want to. Oh, bomb much I'm saying, boo. After now, results of Crano, you hear me.
And I was asking, could you say last week tell them what about you?
I can't drop for
Oh,
you.
but what the quiz nearby?
Quiz in the band is not quite all. Now, more than you. Me was why am manipulation or results? Me was saying you results and my place to must as well yet. What that then? Hey,
I would deal much of it.
Now, when
what
person in your case, you
Broken heart.
now, Mama, stress free is more than about.
On peut do.
Oh, I say, me 2 times 200 view.
What do you actually want to marry?
Oh, I say, boy, I'm really be at 2 or 2 make 1,000 fees view me up and can you oversee.
Sade.
Yeah.
Sade. I say,
Yeah.
about it. Feel stress now. It's Osaka.
Me at 2 times 200.
Hey, sure.
Now 7 men on me, my banner also. I only will.
Oh, me. Hey, rough.
Hey. Lecture number so. Wait. Lecture number so me. Hello. Are you with me? Hello. Yeah, sure.
Challenge you on. What do you create this group now? I'm the better Bakunu Loki. Now I join Loki near there.
That's it.
Okay.
Hey, please don't call. Me come in.
Now we need to see. Charlie, make great content, make great abalabi. Most I think well, as I'm saying, my personal and make great group. Not them no chance.
0553.
When I say what's here, I think I come 0553
88
88
04
04
40
0553 88 04 40. What are maths and science? Maths and science and science and maths.
Math and science.
Very good. Do we attend courses this sem year?
I say, boy, papa, no. Impression they almost 15 years. Yeah.
Me now, me more 8, me more 7, me more 9. Me quite the thinking. Me need baby a fee.
And it's a crampo who had the mind crowd, the Stephens in Qua. A4 sheet, A4 sheet, Kaka agent, out in the oh.
Oh, Charlie.
Yeah, so I don't mean 8 sheets young on the over queen. Boy, bye. You could hear the chair restaurant go.
Okay, Charlie, tomorrow to be away. Hey, where go pilots?
Boy,
I come now. Make of you. I feel like cool.
Charlie, me gig name man. I was there.
What's it?
Let me gig name one yet.
Oh, lie me. Yeah, Jinazo, answer me. Answer me, baby, Jinazo.
Jinazo.
One can come here. Oh, Charlie, never. Quench the price. I'm going to give you so they are the minimum. Quench now got to
Queens.
the quench now got to visit.
Huh? What about that? When
I'm ready. My red, I've gone for Papa. My red, I've gone for Papa. Man, no more penalty and what pay. Hey, what a one man why? 1992 bia.
0540201992.
0540
2019. Yeah, 1992.
05420
Boy.
0540
Yeah,
201992.
yeah.
1 gig.
Me 10 gig per minute.
10 gig 48 cities. No 48 cities at the same IO.
And expired date one.
That be explained it to me.
That may have 48.
1 gig maybe there. Now me 5 gig okay. Maybe I will constant on online. Because me 1 gig, me 5 gig actually for this.
That's not.
Me 5 gig actually for this. Maybe I want your constant.
Me they be online why?
Maybe like who's be one like that. Don't say that thing and mama dey no. Don't say that you travel to make a citizen and me travel.
Me say me can't tablet.
Now what's kind of travel?
I said kind of one will be a tablet. And I will be no should go tablet.
Yeah, what's kind of travel? I'm on there true. I am bumble.
After me pay school ya juma then the mature application or chama sa kwhwe say and then of so abem
Can I hear you at it?
okay Martin, that's it.
Okay. To the later.
Yo onya me nko